All right, in this video, we're going to cover 4.3, right? And 4.1 and 4.2 is just how to do symbols. So definitely just kind of look at your book. Your e-text has all the tables. When you do the homework and the quizzes, I tried to pick problems that had the symbols associated with the problem, right? So basically a symbol equals a number, and then you add up the symbols. And so we'll cover all kinds of different things from Egyptian to basics of numeration, ancient Roman, and such. So use your book for this quiz this week. I also have it where those features are turned on for the quiz, just because I don't expect any of us to have those kind of things memorized. But 4.3 goes into expand to a couple things. First, we'll cover expanded notation. And here in my notes, as you can see, I have a link to how to use an abacus. It's just a cool information video. And one of the quiz problems just has you read the number off an abacus. And then I have a video for Lattice Math, where I'll also do some Lattice Math here in this problem. All right, so let's get started. Expanded notation is when we write out numbers using exponents, powers, to the base 10. Right, so kind of a review. If I have 10 to the third power, this equals 10 times 10 times 10, which equals 1,000. So this 3 is our exponent, or our power, and the 10, there we go, the 10 is, the base, right? So exponent notation always is base 10, but things don't always have to be base 10, right? Because if I have 2 to the fourth power, that is 2 times 2 times 2 times 2, which equals 16. Anything to the 0 power is 1, and anything to the first power is itself. The key to the 0 power, anything, right? Even a variable, x to the 0 power also equals 1. Anything to the 0 power is 1. So that's kind of a quick review of exponents and powers. It's our exponents and bases. So how do we do expanded notation? Well, expanded notation is when you take a number, say 372, and we break it apart. So this is the same as writing 300 plus 70 plus 2. And now I can also break it down further to 3 times 100 plus 7 times 10 plus 2, right, times 1. And then if I want to go to the base power of base 10, I would do 3 times 10 squared plus 7 times 10 plus 2 times 10 to the 0 power, and he has a 1 on it. So if you notice when you're doing these kind of things, right, they keep going down by 1. And you might say, why would I ever do this? It's so much easier to just write out the number. Correct. But when we get into 4.4, conversion between bases, we have to take a number and turn it into expanded notation, and then change our base, in this case base 10, to another type of base. And this is typically how binary math is done for computers, right? And so that's why we're learning this is for computers and computer programming, and all the other computer knowledge for most of the students who take this class are interested in. Okay. So say we want to add 427 plus 383, right? And this is where it kind of gets a little tricky, but I'll still try to go through one problem so you can see it. If I write out this, I get 400 plus 20 plus 7, and then 300 plus 80 plus 3. Now, to add right here would probably be the easiest thing to do. But just to apply the lessons from this course, this is what we shall do. This becomes, again, 400, 4 times 100, plus 2 times 10, plus 7, and then 3 times 100, plus 8 times 10, plus 3. Oops, I forgot to put my times ones in here. And then 4 times 10 squared, plus 2 times 10 to the first, plus 7 times 10 to the 0, and then 3 times 10 squared, plus 8 times 10 to the first, plus 3 times 10 to the 0. And now we can add these. So we get 10 plus 10 to the 0, again 10 plus 10 to the 1, and then 7 plus 10. Sorry about my clock. Squared. All right, my plus. But now you can see every other time I had a single digit. Now I have a double digit here. So that means I got to rewrite him as 1 times 10 to the 1 right, because that's 10, plus 0 times 10 to the 0. It's kind of like I'm on borrowing, right? And then this one becomes plus 1, no, plus, sorry, that's supposed to be a times 10 squared plus 0 times 10 to the 1. Sorry, I lost my train of thought for a second. And then 3 times 10 squared. Nope, not 3. I'm messing up here. He is the same, because we already did our add-in, sorry. So it's a 7 plus 10 squared. And now we can combine like terms. So we have this group. Actually, let me do this. Let's undo that. And go to highlighter. So I can combine these like terms because they're the same base and same exponent. And I can combine these like terms because they're the same base and the same exponent. And then so 7 plus 1 is 8 times 10 squared. And then this becomes 1 plus 10 to the 1 plus 0 times 10 to the 0. Oh, 0. All right, I write a 2 there. And then finally, I can rewrite this out. So this becomes 800 plus 10 plus, remember anything? Oh, that's times. Why do I keep writing plus? Sorry. Keep writing pluses, and those are supposed to be times. That becomes 10, and then anything to the 0 power is 1, and then 1 times 0 is 0. And so our final answer becomes 810. Sorry about confusing the pluses and minuses here. We times the number by the base, and we add the other bases when we finally get our number of 810. Again, a very unique way of doing things, but it is just a practice before we go into the next section of 4.4, conversion between bases. All right, so the next thing I want to talk about is lattice math. So the way lattice math works is a way to multiply. And so say I want to multiply 367 times 42. Well, what I do is I create a box, which kind of looks like lattice, like the stuff you see on porches or in gardens, right? So I have a 3, a 6, and a 7. So I draw those lines down to separate each one into its own box. I have a 4 and a 2. I draw a line over to separate those two numbers in each box. And then I draw diagonals cutting the boxes in half. All right, and so there is my lattice. And now what I do is I take the numbers and I just multiply them. All right, so we'll start there. So 7 times 4 is 28. And then continue this way. 6 times 4 is 24. And then 3 times 4 is 12. And then I go on to the next row. Right? So now I am here. And I'm going to go the same thing. So 2 times 7 is 14. 2 times 6 is 12. 2 times 3 is 6, so I have to put a 0 here and a 6. And now what I do is I keep my diagonals together. So I have my 4 here, that's a diagonal. And then I have this diagonal. And then I have this diagonal. And then this diagonal. And finally, the one guy that's all by himself. And I just write the numbers outside as I add them. So these will all become pluses. So I have nothing to add to 4 to, so he's just a 4. Right, so 8 plus 1 is 9, plus 2 is 11. So now I can't write 11 here. Everything has to be a single digit, so I then have to carry him over to this box. So I add him to the purple row, so there's my 1. And so I add these guys together. 1 plus 2 is 3. Plus 4 is 7. Plus 1 is 8. Plus 6 is 14, so he becomes a 4. Again, I have a carry a 1 up because of 14. Add them. So 1 plus 2 is 3. Right? Put 1 plus sign there. And then plus 2 is 5. Plus 0 is still 5. And I have no carry there. And then I have my 1. And then what I do is I write the numbers going in this direction. So 1, 5, 4, 1, 4. So my answer is 15,414. And we can do this again with a bigger problem. So we want to multiply 387 times 254. So again, we write 387. So now I have a much bigger box. Here's for my 3, there's for my 8. And then, what did I say, 254. 254. Bigger box. Bigger box. And again, we got to cut these things in half. So let's see. To create our lattice. And then we start multiplying again. 2 times 7 is 14. 2 times 8 is 16. 2 times 3 is 0.6. Try to have neater handwriting so you don't mess up your numbers when you go to your add. That happens to me sometimes. 5 times 7 is 35. 5 times 8 is 40. 5 times 3 is 15. 4 times 7 is 28. 8. 4 times 8 is 32. 4 times 3 is 12. And now we start to add our diagonals again. So I get an 8. And then 5 plus 2 is 9. 4 plus 3 is 7. Plus 3 is 10. Plus 2 is 12. And then be careful, I go into the right row, so I'll put plus 1 there. 6 and 4 is 10. Plus 5 is 15, 16, 17, 18. Carry the 1. 2 plus 6 is 8, plus 1 is 9. So my answer is 98,298. So in the readings, they kind of show how to also do some add and subtraction through expanded notation, just again, to kind of practice. This is different types of math. It's kind of what section 4 is. It's right numbers and kind of like the history of numbers in different ways. Calculations are done other places. But again, the big reason we're going to go into the next video is how we convert between number and bases. And the most common that we want to do is base 2, base 8, and base 16 for dealing with computers. All right. So I hope you found this video useful. Email me if you have any questions, and have a wonderful day.